name's Scott Turnbull. I'm the CTO at Fidus Systems. If you haven't heard about Fidus, Fidus is a custom embedded systems design and services company. And one thing that's been core in our DNA for the last 25 years is that we're not successful until you, our clients, are successful. So, do you think you could be successful with Fidus? Well, I'll ask you a few questions here. Are you getting pressure to get your product to market faster? What would you do with time to focus on, say, higher priority or different items? What could Fidus bring to your team with our extreme AMD expertise? Would we be able to get your product to market faster? Would we be able to help train your team in all the newest AMD technologies? What about scalability? Anybody have that problem where it's more projects than people? So we can quickly join up and help you through that. And then alignment. You know, one of the things we hear a lot is, well, yeah, but how do you work with us? We have a very distinct process or approach to things. We're very flexible, we adapt to that. You work within your process, we have our own processes, but we know that it's important to fit into yours. And then in terms of flexible engagement, you know, we know that not one size fits all, so we try to address that, and I'll talk more about that in a bit. So we were the first AMD Premier partner in North America. That was in 2011, and we're proud to be a platinum sponsor of these ECS events. So here are just a few of the hundreds of brands that answered yes to one or more of those questions I just asked you. Now, really briefly about us. So I mentioned we're about 25 years old. We've got over 400 really great clients. We've delivered thousands of projects. We're about 150 plus engineers. But the one thing that I'm most proud of on this slide is the big orange repeat client rate. So that rate says that people value what we bring, but even more simply, they enjoy working with us. So that is something that we really focus on, and that comes from our thing that I mentioned at the beginning, your success is our success. Now, what are these numbers up here? These are actually the number of products that we've delivered based on the AMD technology by family. So I think this is pretty impressive. I don't think there's a lot of companies that can say that they've done this level of work with these AMD parts. One thing I guess I'll off-road a little bit here is on the Versal RF. So we just completed our first Versal RF design, and we're gonna send that one into space. And so what happened was a client actually came to us with an architecture, and it was a pretty traditional architecture where you know, it was a radio card-based system. There were the up-down conversion stages, then there were a bunch of ADCs, and then there was a Versal device backing it up. Well, we did a pretty extensive analysis on that architecture, and we're looking at size, weight, and power. And the Versal RF just killed that architecture. It's like, just put a Versal RF in here, you save a lot of power, you save a lot of space, and you simplify the radio card significantly. So that's what we're putting into space in a couple of years. And I mentioned size, weight, and power, but the cost for that solution was significantly less than the cost of that traditional architecture too. So we had the full swap C there. Now I said not one size fits all, but Fidus can't fit all. We're very flexible. We like to engage in a turnkey or staffing environment, whatever you prefer, whatever you need, whatever adds the most value to you. Business models, time and material, fixed price, or flexible. We know that different companies have different requirements at different stages of their life cycle. And then expertise. We can bring a full range of expertise, sort of a one-stop shop to help you get to where you need to be. So Beth was talking about heterogeneous computing. We're starting to see a lot of requests for x86 embedded. And the sort of term used these days, or what we like to use, is embedded plus. The idea of pairing that x86 along with a FPGA, whether it be a Spartan or adaptive SoC like a Versal, that makes things super powerful. And I talked about swap before, and what we're seeing is that swap is great, but performance is now even more critical than ever. So I don't know if we need a new P-swap or a swap CP or something like that, but that heterogeneous computing, whether it be like CPU, FPGA, GPUs, NPUs, the porting of the right function to the right processing element gives you that power in that swap technology. Small. We're all familiar with the idea of taking a PC and putting a PCIe FPGA card in there for some kind of acceleration offload, something like that. That's okay for some applications, but in today's world of edge applications, that's too big, too power hungry. So we're looking at full embedded systems, x86, single solutions board down. Familiar? Everybody knows Linux, Windows, whatever it happens to be. So if in the medical industry, now you can have a Windows PC, it's up on their network like they're all used to, but you have the processing power of an FPGA behind it as well. And then flexible. So FPGAs have been known for years for being extremely flexible, especially in terms of I/O. So we've released this Fidus Vision Stick. And no, we're not primarily a products company, but every so often we'll invest in an AMD-based product. And what this shows is that you can have an M2-based card with an Ardix UltraScale Plus on it, and this ingests 4 GSML2 cameras. So no longer in the x86 environment are you limited to Ethernet or HDMI or DP or anything like that. You can now put like these little cards in there, bridge whatever you want into that x86. So very simple type approach to something, but hugely useful. Now we're gonna change gears a little bit here and talk about something technical that's core to everything that we do. And that's signal integrity and power integrity. Now, Fidus has never been known for doing the simple stuff. We've always been on the leading edge, doing the really complex stuff. And so what I wanted to do was sort of like walk you through an example of what we do signal integrity-wise in order to ensure first time right when we're doing the latest technologies. So this is an example of a PCIe Gen 5 simulation that we did. So it's a pretty complex system. You'll see the full topology in a second. But here's our process. So we start with the layer stack. So the layer stack has input, right, from the layout designers, from the hardware engineers, from the signal integrity folks, as well as manufacturing. Never forget about manufacturing early on. And then what we do is we model the most complex areas. So in this case, we're showing like a BGA style breakout. So how do we break this out? What kind of performance can we get? Once we do that, we simulate that breakout. So we're looking at crosstalk, we're looking at insertion loss, we're looking at return loss. If we're happy with the way that that looks, what we'll do is we'll go on to the next stage, where we'll model the entire channel. So this is from the edge of the die, through the package, and every individual package, as you guys know, have different parameters. Down onto the board, through vias, through backplane connectors, what have you, up backplane connectors, and then end somewhere, some sort of receiver. It could be another die, or it could be like a high-speed optical transceiver. So that whole system is simulated and modeled. Now at this stage, the layout's still ongoing, so all the lengths are just estimated lengths. And again, we look at crosstalk, we look at insertion loss, we look at return loss. And then we just sort of repeat that cycle until we get what we want to see out of it. Most of the time, we have a dedicated signal integrity group. These guys are world-renowned in that space. Most of the time, we go through this cycle once, and we release the board, and it works great. So, what would an AMD event be without some really cool demos? So we heard about some of the demos that we have later on today. Our demo is going to be a pretty cool one. You know, this featuring the Ryzen CPU. It's got some GMSL cameras, YOLO re-ID functions going on. Showcases Rocco, so that GPU acceleration that's going. And we got some vector visualizations. Now, anybody familiar with re-identification here? No? So what it is kind of a really creepy technology where you can have multiple cameras follow you around and identify who you are and when. So think about walking through an airport and you say, okay, that person looks a little bit sleazy. I'm gonna train on them. So you train on them, and then you can follow them throughout their cycle through all the rest of the cameras. So we have a little miniature version of that. Anyway, with that, I invite you to come see us tonight. Thank you for listening, and thanks to AMD for having us.